Okay, this is the continuation of the mirror video. We're going to talk about lenses and ray tracing and how to use those equations with lenses. Lenses let light pass through them, and so we're going to use the same equations here, the lens or mirror equation. Once again, let me focus this down real quick. Hey, focus using the lens. The equation up here, this is a lens or mirror equation. This is 1 over the focal length of the lens or mirror, equaling 1 over the distance of the object, plus 1 over the distance of the image, and that's in relation to the lens or mirror. This is the magnification, that's equal to the height of the image divided by the height of the object, or it's negative the distance of the image divided by the distance of the object. We're going to use that one a lot. These are our two optical devices that we'll be using. These are going to be your thin lenses, and so for the first one, that's like a magnifying glass. The magnifying glass, light will go down to a point once coming in horizontal. So you can use that feature to burn stuff, of course, or to make stuff bigger. And that's going to be dependent upon your ray tracing and how to figure that out. And again, this is called convergent. So this is convergent. Light comes down to 1 point. It's going to spread out after that, but it does come down to 1 point. For this one over here, light is actually going to spread apart, and it's going to spread apart in a manner consistent with a focal point. Might not be as obvious, but there is a focal point to these lenses. It's going to be on the other side of the lens, and so you should be able to trace these rays back on through to that focal point. Okay, light never truly gets focused down to it, so this is going to be a divergent device. Doesn't cooperate very well. Okay, so we're going to start off with the regular magnifying glass. I'm going to draw it right over here, and again, drawing just a vertical line there is really going to help you out. You can imagine this as a magnifying lens on either side with a curve, but really we use this vertical line, and this is going to be our convex lens because it's sticking out on the sides. Remember, convex sticking out, concave sticking in, and it's going to have two focal points. It's going to have a focal point over here, and it's going to have a focal point over there. And what this says is that, you know, it doesn't matter if you flip the lens back and forth, it's still going to do the exact same thing. We're going to place an object. Let's place our object out here, and let's see what happens to that object. So the three lines do apply again. We're just going to go straight back through that. The first line, though, that center of curvature line that we drew with the mirrors, it's actually going to go straight through the center of our lens. And so if you imagine this lens works off of refraction, if you go straight through the center of the lens, it's not going to ever have to refract at all. So we're just going to do that. So first line, top of the object, straight through the center, comes out the other side, no big deal. The second line is going to go, and again, pause the video if you're drawing along with me. Feel free to do that. It is a video. Second line is going to go from the top of the object straight on through till it hits the lens, and this lens is a magnifying glass, and you got to remember what kind of lens it is. Magnifying glasses make light bend downwards, or it refracts light downwards, like so. And so we already have a crossing point of these two lines right around here. We're going to do the third line just to make sure. The third line is going to go from the top of the object straight through the focal in front, because that's the one we haven't used yet. And then once it hits our lens, it's going to straighten out. And so if we do this, then we see that our lines meet up somewhere around there, and that will be the top of my image. And remember that it's not an arrow that I'm drawing to say, hey, there it is. That's the actual image. Okay, little upside down person, if that's an actual person. So let's work the math real quick. I've got 1 over f, the focal point. The focal point is 1, 2 away from my lens. So I'm going to use 2 there. And light actually gets to go through it, so it's going to be positive. That's equal to 1 over do, the distance of the object, 1, 2, 3, 4, plus 1 over di, and hopefully it turns out to be 1, 2, 3, 4 as well. So moving this stuff around, I've got 1/2 minus 1/4 equals 1 over di. Let's see, we can make this a little bit better. 2 over 4 minus 1 over 4 gives me 1 over 4. And that says to me that DI has to be 4. So 1, 2, 3, 4. Math works out. Good stuff. Looking at the magnification, I've got negative DI, 4, over DO, which was 1, 2, 3, 4. And this is going to give me negative 1. And so, if magnification is negative, that means my image has flipped upside down, as it shows. And it's 1, so it's a 1-to-1 ratio. The image is the same height as the object, and that is also true. So math works out, picture works out, we're good. If you were to put a sheet of paper right here, have the actual lens with your object, you would be able to see that object upside down, inverted, at the same size as your original. And so this would be a real image. Okay, real and inverted. Let's do another one. Let's see, where should we put this one? Let's just keep that line straight there. Continue that one. Still a convex lens. Let's make the focal point a little bit farther out. Let's make it 3. 1, 2, 3. Now this is going to give me a little bit more room to work with. I'm going to put my object right. Let's put it right here. Okay, so there's my object. And we're going to do our 3 lines again. That first line goes straight from the top of the object straight through the center. Like that. Okay. My second line is starting off horizontal. And this horizontal line is going to hit my lens. And this is where we got to think what kind of lens it is. It's a magnifying glass, so magnifying glasses make the light bend downward towards the focal point. So we're going to go like that. And I'm going to notice immediately that these 2 lines are never going to cross, so I'm going to use my ray tracing properties and trace that refracted ray straight back. Just like with mirrors, you can trace the reflected ray back, you can trace the refracted ray back. And when you do that, they're going to meet up right over there. Okay. This third line is the tricky one. We've already used up the focal length, the focal point on the right side of the mirror. We're going to use the other side. And so this is that one thing that you're probably going to get tripped up on. So using the focal point that we haven't used yet, we're going straight through it, coming up, hitting that lens. And since we've already gone through one of our focal points, we're going to straighten out again. So our line straightens out, goes off into infinity, but I'm going to go ahead and trace that refracted ray back. And so what we get is right there should be where my image is located. Okay, and it looks like it's going to be a little bit bigger than my object. It's definitely going to be virtual. You can't put a piece of paper there without blocking the incoming light in the first place, so you can only see it, you can't project it. Time to work the math. Let's just see if we're right. So 1 over f is 3. That's equal to 1 over do, which was just 1, plus 1 over di. That's what we want. So I've got 1/3 minus 1 over 1, which is actually going to be 3 over 3. That's going to net me a negative 2/3. And that's equal to 1 over di. And so if I look at this, di should be equal to the flip of 2/3, or negative 3 over 2. And so the question becomes, is our distance of the image 1.5? And that's 1, that's a half, and that checks out. So that's the distance of my image. Notice that it's negative. It's on the other side of the lens where light is coming from. The light's going to go through the lens, end up over here, negative if the image ends up on the other side. The magnification is negative di over do, so negative 3/2 over do, which was going to be just 1. So we have negative becomes a positive 3/2. Does that check out? Our image, is it upright? Check. Is it about 1/2 times bigger? Check. That's good. So it works out. This would be a virtual image. So before it was real, we could project it. Now it's virtual. We can only see it. can't put it on paper without blocking off the light in the first place. Last one, getting on down there. This will be a shorter video compared to the last video. Let's do a concave lens, and let's move it over just a little bit. Let's put this, actually no, we'll keep it in the middle. Let's do that right there. Make sure we say this is concave and it's a lens, just so we know what we're talking about. All these are lenses, by the way. If you want to look at mirrors, go check out that other video. Let's make the 1, 2, 3, the focal point the same. 1, 2, 3 as the last one. But we need to keep in mind what a concave lens does. A concave lens is divergent. Horizontal light comes in and it spreads apart in a noticeable fashion. So let's put our object, where do we want to put it? Let's put our object over here. Okay, so there is my object, and let's do our 3 lines. The first line is the easy one, it goes straight through the center. And this object goes right there. So that's my first line. Easy line to remember, straight through the center. The second line is going to go horizontal starting off. And I always do the second line as a horizontal one because you sometimes get mixed up, or at least I get mixed up if I don't do this. So, horizontal line. What are we working with? We're working with a lens, so it's going to go through, but we're working with a divergent lens, so it's going to go up. All right, and it's going to go up in such a way that the ray trace should be able to be traced back through the focal point. So check that off. There's our light going up that way. Got a crossing point over there. That's pretty good. Last one, we're going to go and use the, this is where it gets kind of messy, so look at how it looks like right now. The last one is going to use the other focal point that we haven't used yet. So we're going to use this focal point. So we're going to go straight towards it. That's set up. We're going straight towards that focal point, but do we ever get there? And the answer is no. Hit the lens. What's the lens going to do? Going towards the focal point, there's a lens. It's going to make it go straight. So we're going to straighten this sucker out. And if we do that, there it goes off into the infinity, but we can trace it back right there. And that crosses over where our other lines crossed, so that is good news. We got a small image, and it's upright. So we're going to have to double check our work. 1 over f. What is f? 1, 2, 3. Does light actually ever truly pass through a focal point? And the answer is no, so it's negative. That's equal to 1 over do. 1, 2, 3, 4, 5. We placed it at 5 out there. Plus 1 over di. We'll leave that as the unknown. So let's move that over. I've got negative 1/3 minus 1/5. And let's make these commons. What's common here? 15. So we've got multiply by 5, negative 5 over 15 minus 3 over 15. What's negative 5 minus 3? It's going to be negative 8 over 15, and that's equal to 1 over di. So di will be the flip of that, negative 15 over 8. So what is that, a little less than 2? Hey, look, it's a little less than 2, isn't it? 1, 2. So that checks out. Do our magnification, very last step. Magnification is negative di, negative 15 over 8. Over do, which was going to be, what again, 5? 1, 2, 3, 4, yep. And so let's see, that negatives cancel out. I've got 15 divided by 8 times 5, so 40. Can we reduce that at all? Let's see, divided by 5, that's going to be 3/8. Yeah, look at that, let's see. Upright, checked out. Less than half the size, yeah, checked out. So that works out. Concave lenses always give you virtual images. They're upright. You put a piece of paper there, can't see it because you blocked all the light in the first place, dummy. There you go. that is the little lecture on lenses and ray tracing. Hopefully you find this useful. Practice, practice, practice it if you want to get it. This is the end of this video.